Here, it's actually 5.2. It's the bottom of that page from yesterday. Sorry, I did erase your line. Very, very quick. This is all the notes we're doing today, and then you can get started on your extra practice. It's pretty much a review of what we did yesterday. It's a little different because yesterday you were told you had a parallelogram, and then you had to apply those properties to solve for different parts. Today, you're going to be given a quadrilateral, and you have to take the information to determine whether or not it is a parallelogram. So just by definition, by the name, both pairs of opposite sides are what in a parallelogram? A parallelogram they are parallel, just by its definition. A parallelogram, opposite sides are parallel. So if you're given a diagram like this, then your answer is yes. Parallelogram because opposite sides are parallel. And the next one, it says, if both pairs of opposite sides of a quadrilateral are what? If it's a parallelogram. We were talking about yesterday. Opposite sides are parallel and they're also congruent. So if you're given a diagram that looks something like this, where the opposite sides either have the same measure or the same markings like that, then you know it's a parallelogram. So your answer is yes, opposite sides are congruent.
And opposite angles are the same, right?
Yep, so for the next one, if both pairs of opposite angles are what? Then you know you have a parallelogram. So it looks something like this, then you know it's a parallelogram. Opposite angles are congruent. We also talked about yesterday, so what do the diagonals do to each other? They bisect. Yeah, so if you have something like this where the diagonals, these pieces have the same measurement, or these pieces have the same markings, then you know it's a parallelogram. Here's a new one that we can use. If one pair of opposite sides, so one set of a quadrilateral is both parallel and congruent, so this set right here, they're congruent because it has the tick marks. It's also parallel because it has the arrows. We know that's a parallelogram. So if one set is both parallel and congruent, then we know we have a parallelogram. A little section at the bottom of the last page. And again, we talked about kind of if one angle is supplementary to both of its consecutive angles. So if we look at, let's just say this diagram, this bottom angle. If it's supplementary, meaning they add to what? 180. So these two angles add to 180. And then this angle and this angle add to 180. Then you know it's a parallelogram. So the angles that are right next to each other add to 180. Then you know it's a parallelogram. Questions over there? So taking those properties from yesterday.
If two angles add up to 180,
that are
next to be a parallelogram.
Next to each other has to parallel.
Can't be like a rectangle.
A rectangle is parallelogram.
Oh.
And we'll talk about that on Monday. Questions? Other questions? Those are good questions. Right? So this next section, we're going to take that information to determine if the following quadrilaterals are parallelograms. Explain your answer. So take a look at A. Is that a parallelogram? Yes, no, maybe so. That's a parallelogram.
Yes.
Yeah, why?
Aaliyah?
Good, the opposite angles are the same. This is 115, that's 115. This is 65, that's 65. So yes. Opposite, I'm going to abbreviate, angles. You could have also said yes, because the consecutive angles are the angles next to each other, add to 180. That also would be the appropriate answer. The equal angles are easier to recognize. Is B a parallelogram? Why? Yeah, how do you know they were parallel? Yeah, the arrows. Good. How do you know they were congruent? We'll pick marks. Oh, yes. Because of this guy right here, this theorem. One set of opposite sides are parallel and congruent. How about C? Any trapezoid? Any trapezoid? Is that a parallelogram? It's a quadrilateral, you are correct. But is it a parallelogram? Why? Let's draw one. Sometimes we can have visual. So remember, trapezoid has a small bottom and a larger base, and the sides just trapezoid. Is that a parallelogram? Why? Yeah, very good. If you extended these sides, so I'm going to extend this side, and I'm going to extend this side, what would eventually happen to them? They would intersect. What do we know about parallelograms, though? Are their sides going to intersect? Oh, they're parallel. No, not all sides are parallel. These two are. This guy and this guy are parallel. So those two, we call them legs, and we'll get the trapezoids here later on in this unit. Those are not parallel. Yep, that is all. Questions over this?